Natural resources are materials or substances that occur naturally within the environment and can be exploited for economic gain. They include renewable resources, resources that can be replenished naturally over time, such as solar energy, wind energy, and biomass. Non-renewable resources, resources that cannot be replenished within a human lifespan, such as fossil fuels like coal, oil, natural gas, minerals, and metals. Biotic resources, resources obtained from the biosphere like plants, animals, and fossil fuels. Abiotic resources, resources that come from non-living, non-organic material like water, air, and minerals. Assessment of natural resources involves evaluating the availability, quantity, and quality of natural resources. Methods include field surveys, direct on-site measurements and observations, remote sensing using satellite or aerial imagery to gather data about the Earth's surface, geographic information systems or GIS, integrating, storing, analyzing and displaying geographical information, environmental impact assessment or EIA, analyzing the potential impacts of resource extraction on the environment. Remote sensing and GIS principles. Principles of remote sensing involve acquiring information about an object or phenomenon without making physical contact. Key principles include electromagnetic spectrum. Remote sensing instruments detect energy reflected or emitted from the Earth's surface, typically in the visible infrared and microwave regions. Platforms, satellites, and aircraft are common platforms carrying remote sensing instruments. Sensors, devices like cameras, scanners, and radiometers capture data. Active sensors, such as radar, emit their own energy, while passive sensors, like optical sensors, rely on natural energy sources like sunlight. Principles of GIS, Geographic Information Systems, or GIS, are tools for managing and analyzing spatial data. The key principles include data layers. GIS combines multiple layers of data such as topography, land use, and population to provide comprehensive spatial analysis. Spatial analysis. Techniques like overlay, buffering, and spatial interpolation are used to analyze geographic patterns and relationships. Visualization. GIS creates maps and three-dimensional models to visualize spatial data and analysis results. Digital image processing and ground truthing. Digital image processing. Digital image processing involves manipulating satellite or aerial imagery to enhance its quality and extract meaningful information. The key steps include pre-processing, correcting sensor errors, atmospheric distortion and geometric misalignments. Enhancement, improving the visual appearance of images through techniques like contrast, stretching and filtering. Classification, categorizing pixels into land cover classes such as water, forest, and urban, using supervised or unsupervised methods. Change detection, identifying changes in land, cover, or use over time by comparing images from different dates. Ground truthing involves collecting field data to verify and calibrate remote sensing and GIS analyses. This process includes sampling, which means selecting representative locations to collect field data. Then there's validation, where we compare field observations with remote sensing data to assess accuracy. Finally, calibration is about adjusting remote sensing models and algorithms based on field data to improve reliability. Applications of remote sensing and GIS. Land cover, land use planning and management. Urban sprawling, monitoring and managing the expansion of urban areas to optimize land use and infrastructure development. Vegetation study, assessing plant health, species distribution and biomass production for agriculture, conservation and forestry. Forestry mapping forest cover, monitoring deforestation and managing forest resources sustainably. Natural resources, identifying and managing resources like water, minerals and energy through spatial analysis. Waste management, site selection, identifying suitable locations for waste disposal and recycling facilities, monitoring, tracking waste generation, disposal patterns and environmental impacts, planning, designing efficient waste collection, transportation and treatment systems. Climate change. Impact assessment. Analyzing the effects of climate change on land cover, ecosystems and human activities. Mitigation. Identifying areas vulnerable to climate change and planning adaptation strategies. Carbon sequestration. Monitoring forests and other ecosystems that capture and store carbon dioxide to mitigate global warming. These principles and applications illustrate the vital role of remote sensing and GIS in modern natural resource management and environmental planning.